Hey, so welcome back. So in today's video, we're going to talk about data acquisition devices. Remember from the previous video, we were talking about serial communication devices. So I told you that we have one of the two different devices that you can have in the lab is either the serial communication device that I talked about, the RS-232 kind of serial communication and the cables, and the USB to RS-232 box that you can purchase to have this flow of connection between your computer and the LabView and your instrument. For today's video, we're going to talk about the data acquisition devices. So when you, if you, for example, need to measure the pressure, you will go ahead and then you purchase a pressure transducer from a company, say Omega. And when the pressure transducer comes, it has all these like sensors and circuits and everything that is needed inside of it, and it comes with like 2 or 3 cables, positive, negative, or sometimes the null or the ground. And when you purchase this sensor or this transducer or this transmitter and all these things, they have some information, meaning that they said that either this sensor is working with a voltage or with current. It means that these cables they send certain voltage or a certain current. In terms of voltage, they are usually between 0 to 3 volt DC, and in terms of currents, they are somewhere between 4 to 20 milliamps. And usually they are linear. What does linear mean here? For example, if you want to measure pressure and your instrument can measure pressure from say minus 15 psi to positive 15 psi. So that's what your pressure transducer, this is the capability of your pressure transducer with all the springs and circuits and all the connection that is inside of it. The company says that this pressure transducer can measure pressure between minus 15 psi to plus 15 psi for 0 to 3 volts DC. And there's also another thing, and that's called an input voltage, meaning that your sensor has to be connected to some input power or voltage to be operated. And most of all, it's a DC voltage again. So for example, if this sensor, for example, needs 9 volt DC to operate. But once you have provided that 9 to 10 or 12 volts DC to that pressure transducer, that pressure transducer can give you the results in terms of what is the pressure that it is reading in from 0 to 3 volts DC. So there are 3 things. One is the pressure range that this sensor can read from minus to 15 psi. 2 is the power that this pressure transducer needs to operate, mean like it needs 12 volts DC of power. And 3 is the conversion from the pressure to the volt. And that conversion is always mostly from 0 to 3 volt DC. It is working based on voltage. And if it's working based on current, it's from 4 to 20 milliamp. So it means that minus 15 psi provides 0 volts DC if it's based on volt, and plus 15 psi provides 3 volts DC. And if it's based on current, minus 15 psi provides 4 milliamp, and plus 15 volts DC provides 20 milliamps, and the ratio is linear. So for example, if this is working based on volt and based on 0 to 3 volts DC, and it's working from minus 15 to plus 15 psi, so at 0 psi, which is exactly in the middle, you will get a 1.5 volts DC. So this is basically linear. So I'm going to say this one more time. So when you purchase a pressure transducer, a temperature transducer, a pH temperature transmitter, an actuator, that everything that you purchase, it needs a power first. It needs some kind of electric power to basically operate. So it needs an input, a power to operate. And that is what the company tells you, that for example, how much of the volt is needed for this specific sensor to actually work. So that's one thing. And usually they work with DC volt. Some of them might be different. So that's one thing that you should know. And the cables that come with the transducer or your sensor, one of those cables are for the power, for the input, for the electric power, so that the sensor actually can operate. The second thing is that what is the range that that sensor can read in terms of, for example, pressure means psi, temperature or centigrade, pH in terms of, for example, from 0 to 14. So that's one thing. The other thing is that if you convert this actual reading that this sensor should have into a volt or to a current, what is this? So, and because it's always from 0 to 3 volt DC or from 4 milliamp to 20 milliamp, 95% of the time, like all the sensors that I purchased so far, they all work like this. So you just have to find a linear conversion from volt or current to whatever the actual reading is on this sensor. So for example, if you have a thermometer, a thermocouple, or something that measures a temperature, and it can measure a temperature from 0 to 100 degrees C, from and that reading in terms of volt is from 0 to 3 volt DC or from 0 to 5 volt DC. What it means is that 0 degrees C is 0 volts and 100 degrees C, for example, is 5 volt DC. I think it's mostly 5 volt DC. I don't remember whether it was 5 or 3 volt DC, but it's one of these. I mean, depending on your on the sensor that you purchase, clearly on their website they define that. So I will go to one of the websites that, for example, they sell a pressure transducer, and I will show you what I mean exactly. So, for example, on the Omega website, they are selling this low-cost pressure transmitter, and you can see that the pressure range that they have is from 0 to 15 psi and so on. So if I choose the 0 to 15 psi, it's going to measure the absolute pressure and the accuracy value and all these things. You don't care. It's saying that the output signal is the current, and the electric output is based on current is from 4 to 20 milliamp. So that means that 0 psi is 4 milliamp and 15 psi is 20 milliamp, and everything in between is actually linear. So 10, for example, 7.5 psi is exactly like 12 milliamp. So all you have to do is to find the ratio and get the equation out, and then you are in your LabView program. Uh, your uh, your data acquisition system is going to measure the signal in terms of current, for example, for this specific instrument, and then you get the current, you know the ratio, a simple math, and then you can transfer that current into a pressure in terms of psi. So it's as simple as it is, and it's always linear. Like all these websites that you purchase, a transducer or transmitter, they are mostly they are always like this. Their ratio is always linear. So that was a current. Let me see if I can find a voltage one. Yeah. So it was 5 volts DC. I'm sorry, not 3. Um, so this one again. Let me close this. This one again is saying that this is reading pressure from 0 to 30 inch of water height in terms of the signal, and it's in terms of the voltage signal, and it's from 0 to 5 volts DC. So yeah, it can either be a voltage or it can be a current. So for example, this is the voltage one, and it's in the millivolt. This is in the volts DC, and the range. So just look at whatever sensor that you have in your lab or you have purchased, and look at the information of them on their website, and see what range they read of whatever thing they are reading, and what is it in terms of the voltage or current, what is the range that they are reading. And this is really important. So so this was all about talking about sensors, and that sensors can give current or voltage signals, and then you can, from their website, you can know how they work. But we can have two types of the of the signals, an input or an output. So let's talk about that now. So In the real world, most of the data that we have are in the form of analog in nature. And I talked about analog, and I told you that analog is like it has like this continuous wave. So it's not binary, so it's not digital like 0, 1, 0, 1. You can see here we have this continuous signal. And here for our case is current or voltage. So for example, if you're talking on a microphone, if you're someone talking on a microphone and you're producing some sound wave and this microphone is transferring that sound wave into a current or a voltage signal and it produces an analog signal. Then you need to have an analog digital converter which converts these analog signals like voltage or current into digital signals that can be processed by computers. This part can be done by a data acquisition system or a DAC device. So you are talking on a microphone, you're producing sound waves, and the microphone transfers that sound waves into a voltage or current signals. And that signal, the voltage or current signal, has to be transferred from being analog to digital signal so that your computer can understand it and see what it is. And then if your computer wants to play that sound back to you, that we need another data acquisition system that can convert that digital signal to an analog signal, so you can have a speaker. That digital signal, that 0, 1, 0, 1 kind of signal that is in your computer can be transferred to a voltage and current, and that voltage and current can be played by a speaker. So you need an ADC to transfer an analog signal into a digital signal, and you need a DAC to transfer a digital signal to an analog signal. And all these ADC and DAC can work with a data acquisition system. So data acquisition systems are systems that can transfer analog to digital and digital to analog. So it's both ways. If they are transferring it from analog to digital, we call this kind of sensor like your microphone and all these things as an input. So that means that some signal is getting into your data acquisition system. So your data acquisition system is reading signals. So signals are getting inside the data acquisition systems. So we call them an input. But on the other hand, your speaker and this part is your output. Why? Because your data acquisition system is transferring your digital signal into your analog signal so that a specific instrument here, which is your speaker, can operate. So this is called an output. So data acquisition systems, we have two types of data acquisition systems. The data acquisition systems that are for input, for example, pressure or temperature reading. So these are inputs because you get the voltage or the current from your sensor, and that voltage and current is going to be transferred into some digital numbers with the help of a data acquisition box, and then the digital value, the computer can read that. Or you can have some data acquisition system that is for outputting data, meaning, for example, if you have a valve and you want to tell your computer to open a valve in your system. So then you have to send digital signals, and then a data acquisition system has to convert that digital signal to a voltage signal or a current signal so that your valve can open and close. So this is the meaning of input and output. So I'm going to say again what each one of them are. So devices which perform an input function are commonly called sensors because they sense a physical change in some characteristic that changes in response to some excitation. For example, change in temperature, pressure, pH. So you have a change in temperature and you have a temperature sensor that can detect that change. And that temperature sensor is an input that sends input signals into your data acquisition system. So this change in temperature and pressure is going to be converted into the change in voltage and current, and then the voltage and current, change in the voltage and current has to go to your computer, but computers have no understanding of voltage and current. So you need a data acquisition system that can transfer that voltage and current into a binary or digital form of signals that the computer can understand. On the other hand, for devices which perform as an output function, they are generally called an actuators and are used to control some external devices. For example, if you have an electronically controlled actuator valve or if you have a sound device. So for example, you have a beaker that has a lot of hot water in it, and you have a thermocouple or a temperature sensor that measures a temperature inside your cup, inside your beaker. And the idea is that you want to maintain the temperature inside this beaker at 50 degrees C, but you're continuously adding you can add hot water and cold water to your beaker, but you want to keep it at 15 degrees C. So you have a temperature sensor, which is reading the temperature inside this beaker. And you have two actuator valves that are controlled electronically for hot water and the cold water. So what it does is that your temperature sensor inside this beaker is going to input signal to a box which is called your data acquisition system, and that box is actually this temperature sensor is going to send a voltage signal to the box of data acquisition system, and the data acquisition system is going to transfer that voltage signal into a digital signal and send it to your LabView, into the LabView in your computer. And LabView is going to read that. And it's going to read that the temperature, for example, is 60 degrees C. So now you are going to send digital signal to your data acquisition system that accepts digital signal, so it's an output. And that digital signal is going to be converted to a voltage or current signals, and it's going to be sent to the valve that is connected to the cold water. And for example, you're going to tell open the valve 20%, and then it's going to add cold water in your cup, and then the temperature is still reading the temperature, right? So when the temperature gets to 50, then you're going to tell your actuator valve to stop and don't add any more cold water. So that's why you need a data acquisition system. You need a data acquisition system or a data acquisition hardware or a data acquisition device for inputting and outputting. For example, the system setup that I have in my lab, I don't have any output. I only measure temperature or pH or a pressure. But if I had a valve for some reason, I would have an actuator valve, and that actuator valve is going to be my output. So when you purchase a data acquisition system and you go to the National Instruments website, you have to know what kind of sensors and actuators you have. If you have both the sensors and actuators, meaning if you have both input signals and output signals, you have to purchase a data acquisition device that can do both inputting the data and outputting data. So that means that your data acquisition system can both acquire voltage and current signals and transfer them to digital, and it can also get the digital signals from the computer and change them to current and or voltage and send them to your external device. So before you're building your system, you need to know what kind of sensors or actuator you have, and if you have input kind of signals or output kind of signals, and then you are buying your data acquisition system online from their website, you would know how many input signals you have and how many output signals you have, and based on that, what is the best data acquisition device that you can purchase. So I hope this information that I gave you is useful to you. If you have any question, please don't hesitate to ask me. Yeah, so now let's go ahead and open LabView and let's get started. So what I'm gonna do is that actually I have some thermocouples here that I'm going to use my phone to video that information for you so you will know what I mean. And what I'm going to do is that I'm going to have two cups here in my office with two different like starting temperature. I don't have a hot plate, so I cannot keep the temperature constant. So I will have like two different kind of temperatures in my cup here, and then I also have two different thermocouples that are going to measure the temperature for me. and I am gonna build a LabView program that can measure the temperature on these two cups over time. And I'm gonna show you how this is gonna be done. So wait for my video with my camera to show right after this part.
Here I'm having a thermocouple that you can see this like metal rod is the sensor part that you put it inside a liquid to measure its temperature. And these wires here, you can see there are like two wires. They are the positive and then the negative voltage. So if you purchase a sensor, that it can come with two wires or three wires. If it is a two wires, that means that it's like a positive or a negative voltage, and it can also sometimes have it can also has a third wire that can be the ground. But when you are purchasing a sensor from a company, the company will give you the information on which wire is which and how you should connect them to the voltage or to read the proper voltage or current. So that part you will know from the company, like how to wire them. But usually the positive one goes to the positive voltage and the negative goes to the negative voltage. This is how it works. So here the thermocouple that I have here only provides voltage from 0 to 2 or 3 millivolt, which is really small. So I'm going to show you a circuit right now that I've built that is going to amplify the voltage in this. You don't have to do it because when you purchase a sensor from a company, inside the sensor itself, it has the amplification or amplifying circuit. But because the thermocouple that I could find in our lab doesn't have that amplification circuit, I had to amplify it myself. But don't panic or anything. You don't have to do it when you buy a sensor from a company. It is already amplified. So here I have a circuit to amplify the reading of that. This is not the purpose of this class, so I'm not going to talk about this circuit. And I'm sure you guys are not going to work with it also, because nowadays when you are buying sensors, they already come with the amplification circuit and they are already amplified. Your voltage or your current readings, they are already amplified. So what you'll do is that when you get a sensor like this that comes with a positive or a negative voltage, what you'll do is that you have to use a data acquisition system like this. This is an NI 6009. There are some other kind of data acquisition systems that you can find from their website. They have different models. This is the model that I could find in the lab that nobody was using. And then you can see here it says analog and digital. So it has both the analog and the digital data acquisition system. And because we are using a thermocouple that is producing a voltage current for a voltage signal for us, we are going to go with the analog part. And here in the analog part, we can see we have 1, 2, 3, and 4 channels that started from 0, 1, 2, and 3. So you can connect 4 different sensors at a time. And these sensors are going to send signals. So they are basically an input signals, meaning they are sending voltage or current signals to the data acquisition system. And the data acquisition system change these signals to a way, this analog signal to a way, or basically to a digital signal, so that the computer or LabView can read it. So all you have to do is to basically connect your wires from your sensors to one of these. So here right now, let me focus. So here right now, for example, if you are using channel 0 has a positive and a negative and a ground. So depending on the type of the sensor that you have and the number of cables you will have, you have to connect them to here. So here, because I have this circuit, what I did that eventually after I amplify my voltage from the thermocouple, I will connect the positive to the positive and then the negative to the negative. So the green is the negative, the yellow is the positive. And then this data acquisition system can read the voltage from my circuit. But when you buy your sensor, and your sensor already has an amplifying circuit inside of it, so you don't need to have a board like this. You just come, take your sensor, and easily connect them here, positive to positive, negative to negative, and then you'll be done. So what I have here is that I have two circuits here, so I can have 1 and 2 thermocouple, so that I can show you how to get like acquire two signals from two different sensors at a time. And basically the method that I'm teaching you is for more than two also. It's just whenever you have more than one sensor, what to do and get the signals in LabView. If you have 1, 2, 3, 4, 5, and so on, you can all do it with the same method. So stay tuned for the LabVIEW programming.
So I talked about the circuit that I have here, the thermocouple that I have here, and my data acquisition system. I need to clarify something for you first, because I was listening to my video and I feel like it might be a little bit confusing. So you will go ahead and purchase a data acquisition system, like the data acquisition system that I have here in the lab, and it has like several pins: a positive pin, a negative pin, and the ground pin. And when you purchase a sensor, as I said, you have to provide power to your sensor. So don't just connect the positive to positive and negative to negative, and that's so easy. For my case, it's easy because I'm producing power through my circuit. But your sensor need to have some kind of electric power for it so that it can operate. So please just make sure that you are wiring correctly based on the manual that comes with your sensor, that your sensor has electric power, that it can actually work. So basically it's on, so it can work, and then it can give you the voltage and the current signals also. So it's not as easy as to wire the positive to positive and negative to negative, because you have to have some input power for your sensor to be turned on and to actually work. So just keep that in mind. My circuit here has a power because I've built a circuit board here, but when you purchase a sensor, you have to give it some kind of like DC voltage power also. So just keep that in mind, that when you are connecting your sensor to your data acquisition system, follow the guideline that comes with the sensor itself. So I will stop this video for now, and starting in the next video, I'm gonna open a LabVIEW and then we're gonna program this temperature reading. See you soon.